Hello, my name is Elaine Baker. I'm a geoscientist at the University of Sydney and I work with Grid Arendal, an official collaborating centre of the United Nations Environment Programme. We've been working with UNEP for the last 4 years, looking at the way the world deals with mine waste. Mining is essential for sustainable development, but the benefits of mining shouldn't come at the expense of lives, livelihoods and the environment, which unfortunately is currently the case in many places around the world. It was very depressing to hear on the news last week that more than 170 people had been killed at a jade mine in Myanmar. It appears that heavy rain caused unconsolidated sediment that had been deposited on a slope to fail, resulting in a massive landslide. The people working at the base of the slope were unable to escape the river of mud and were swept away. These workers look for small pieces of jade that are left in the waste pile after the industrial mining has been through. Officially, jade mining in Myanmar is worth $1 billion or so a year, but some experts put the real figure at closer to 40 billion a year. It was another fatal mine waste accident in 2015 that prompted a number of NGOs to ask the United Nations Environment Programme to examine the management of mine waste. Together with international experts, we produced this rapid response assessment report titled Mine Tailings Storage: Safety is No Accident. The report documents the enormous human and environmental cost of tailings dams disasters and examines opportunities to improve safety and encourage innovation in dealing with mine waste. So what are mine tailings and how are they stored? Tailings are the waste left over after the economical fraction has been removed. Typically, they're stored behind large embankments that can reach hundreds of metres in height and are built progressively over the life of the mine, which may be many, many years. They're made out of the mine's waste rock and sediment. The most common methods of embankment construction are illustrated on this slide and are described as upstream, downstream, and centerline. This refers to the direction in which the embankment crest moves in relation to the base. Embankments can be built using one of these methods or a combination. The upstream method generally has the lowest initial cost and has historically been the most popular method for dam construction in areas with low seismic activity. You can see from this slide that the embankment rests on this lighter coloured material, which is actually the tailings. The number of dam failures associated with upstream dams has led to increased scrutiny of this method. Modern tailings dams can be huge. This is the Fort Knox gold mine in Alaska. It's a cross-valley dam constructed using the downstream method. At the end of the life of the mine, the facility is expected to cover almost 400 hectares and contain nearly 300 million tonnes of mine waste. The volume of tailings produced per tonne of ore is increasing because of declining ore grades. Basically, we've mined the most accessible high-grade ores. The total volume of tailings on the planet is currently unknown, as is the number of tailings dams. But the most recent calculations suggest that around 9 billion tonnes of tailings are produced each year. To put that in perspective, that's around 2.7 million Olympic swimming pools. When tailings dams fail, the consequences can be extreme. The disaster that prompted the rapid response report occurred at the Samarco mine in Brazil in 2015. 19 people were killed, and the 33 million cubic metres of tailings that were released caused huge environmental and social damage. The red-stained mud from the iron ore mine destroyed houses, farmland, and damaged an extensive river system. This included 4 water dams that supplied drinking water to hundreds of thousands of people. The plume went all the way to the Atlantic coast, more than 640 kilometres. So what's in tailings? Well, it depends on the ore type and the processing methods. Tailings can range from relatively non-toxic sediments to highly toxic mixtures with high concentrations of heavy metals, radioactive substances, and processing chemicals. This bar graph shows an estimate of the amount of valuable metals contained in tailings released when a tailings dam collapsed in Spain in the late 1990s. Thousands of tonnes of valuable material. Processing efficiency has improved since then, so there may be lower concentrations of target metals in mine waste today. But at many mines, valuable non-target commodities are not extracted during processing and therefore remain in the waste. Because tailings are a source of metals, some are being remined, and there are plans to make this part of the broader rehabilitation process at abandoned and closed mines. However, unfortunately, there is currently little application and no market for most mine tailings. There are alternatives to storing wet tailings in dams. Tailings can be filtered to remove water and produce a stackable material. The method has the advantage of eliminating catastrophic dam failures and conserving water. There are some downsides, which include high costs and the potential for erosion or seepage from the stacked material. After looking at the governance and management of mine tailings and examining case studies of past failures, the authors of the Rapid Response Assessment made some recommendations. These included improving the management of tailings through implementation of best practice standards, increased transparency of operation, and the introduction of mechanisms to improve accountability. The report also called for the development of financial assurance for proper mine closure and the establishment of an insurance pool to protect people and the environment in the event of a catastrophic failure. Some of these initiatives already existed in operational standards, but due to lack of reporting and transparency, it's been difficult to assess the quality of the implementation of these standards. And of course, tailings dams continue to fail. It's hoped that the recently completed Global Industry Standard on Tailings Management will address this and will also provide incentive for the industry to reach the goal of zero tailings facility failures.